Myself, K. Ram Mohan Rao. In this session, we deal with the non-spatial data model. The outline of the session is the background of non-spatial data model, followed by the database, the DBMS, advantages and implications of using a DBMS package, DBMS functionality and architecture. The lecture mainly emphasizes on the relational data model, querying a relational database, and then finally classification of DBMS types. So in this session we are mainly concentrating on the non-spatial data model. The GIS, you are aware that GIS is, we have 5 components. Components of GIS includes hardware, software, data, people, and then the procedures. The data part consists of mainly spatial and non-spatial data. Spatial data, you all know that spatial data is data that deals with the positional values with respect to the Earth. And again, the non-spatial data is a data that deals with the secondary information, attribute data, which is supporting to the spatial information. So what makes GIS unique is GIS handles both spatial and non-spatial information together. That is, the GIS, like any other information system, GIS handles non-spatial information, that is attribute information. In addition to that, it also handles geometry of the features in coordination with the attributes and the behavior. So here the GIS makes connection between the activities based on the spatial proximity. It makes the connectivity between the geometry of the attributes, geometry of the features, along with the attributes and the behaviors, that is the set of rules and regulations. If you see the historical background of the GIS, GIS has developed from 2 independent areas technically. The first one is the digital cartography and the computer-aided design. That is the first discipline. The second discipline is the database management systems, so which we call simply as a DBMS. CAD is basically a feature-based, computer-aided design, and it has the features, but unfortunately it doesn't have the attribute management system. The computers replaced manual cartographic processes, particularly for more tedious work, was focused in the 1970s. When we come back to the database management systems, it is not a new discipline. It is a quite old system. In non-spatial domain, the databases are in use since 1960s. So some of the examples for this non-spatial database management system is accounting, banking information, and then the online reservation systems, and then some of the online information systems. So all these things were implemented in the database management systems. So it is quite old discipline. So these 2 old disciplines have merged together to develop the GIS tool. Now we come back to the database management systems. We will define now the keywords, some of the keywords that are that frequently occur in our database management systems. First, we will define the database. The database we define like it is a computerized collection of structured data. It can also be called as an electronic filing cabinet. It is a repository for a collection of computerized data. Simply, it is a structured collection of data stored in one or more tables. So, in simple words, it can be defined as it is a computerized collection of structured data. Some of the examples for this database is student database. So student database is of this EduSat-based program can be defined as a set of computerized collection of structured data, which forms each student will form independent records. Now after defining this database, so it is now the DBMS, which is acronymed as the database management system. The DBMS is nothing but a tool, a software tool or a software package that allows the user to create and maintain the database. So here in the database, initially we are creating a database with given attributes and the columns. The software package, that is the DBMS package, allows the user to create and maintain the database up to date as per the requirement of the user. So the definition of the DBMS is, DBMS can be defined as a computerized record keeping system whose overall purpose is to maintain the database up to date and as per the requirement of the end user. So a DBMS is a tool, you can say, otherwise it is a package. In real world scenario, we have many more DBMS tools. There are n number of tools. Some of them are proprietary, some of them are open source. I will touch upon some of the popular DBMS packages. So MS Access, you have the MS Access that comes along with MS Office. You have a DB2, you have Fox Pro, you have MySQL, you have PostgreSQL, you have MS Access, and then you have the Oracle, you have Sybase. There are many more applications, many more tools, example for this DBMS packages. Now, with the DBMS package or with the DBMS tools, the user of a database management system can do many more functions. So these are the main functionalities, these are the main capabilities of a DBMS package. With these DBMS packages, a user can add a new file to the database. A user of a DBMS can create a new database, that is a new database, a brand new database. By using this brand new database, I can insert a new data or I can insert a new records into the existing files. This is called as data insertion part. And then the user can retrieve the data from existing files. Once I have the database ready, I can retrieve the data, I can extract the data from the existing database as per the requirement of the user. So there is a language support called as SQL, Structured Query Language Support, for retrieving or extracting the data as per the requirements. So there are many more operators coming into picture to support this retrieval of a query. After that, a user of a DBMS can delete data from the existing files. I can delete a data, I can delete a particular record, I can delete particular file from a database, or sometimes I can completely drop the database from the given DBMS. So these are the many more functions. There are many functions available in this database management system packages in general. So all the packages of the DBMS will support